Hello, my dear students. This is Raman Rana here, mathematics teacher, Cambridge International School, Dasuga. Today we will discuss about transformation. In transformation, we have two chapters, chapter 31 vectors and chapter 32 transformation. We have studied in detail chapter vectors, and for PT1 the syllabus is vectors only. So we will discuss today about the transformation. Transformation, chapter 32. An object undergoing transformation changes in either position or shape. In its simplest form, the change in the position or shape, the transformation is in four ways. One, reflection. Second, rotation. The third one is translation, the sliding movement, and the fourth one is the enlargement. So transformation, first one is the rotation. Rotation with in a particular direction and with a particular angle. The second, reflection. Third, translation, and fourth, enlargement. So in the simplest form we are doing the transformation. Dear students, from this session this topic is very simple. Earlier we have one more chapter, that is matrices, and the topic transformation, it was a little difficult. From this session onwards you have only two topics, one is transformation and one is vector. 31 is vector and chapter 32 is transformation. So here if we discuss with reflection, we'll start first with the reflection. This, reflection, mirror image. So whenever in a transformation, when the object is going for transformation, when the change in its position or shape, that is called image. If we have any object here and it goes either reflection, rotation or enlargement, then that enlarged shape or the position is called image. So let's start with the reflection. If we have any object, like this is any object here, A, B, C, triangle in shape, and here we have, let's suppose this is the line which is called mirror line or line of symmetry. So here in reflection we have a flip, means if this is my hand, when we look it in the mirror, it will change the position. If some alphabets like L, if we are writing L in mirror image, it will be going with flip. So here if this is the mirror line, then here the distance, it will move in this way, equal distance from the line of symmetry. Here this point will be point C, this point is C dash, this is B dash, and here this is A dash. So the distance, the perpendicular distance of point, if I am talking about point A and its image A dash, the distance from this line of symmetry is the perpendicular distance of both these points is always equal. Same for the every point. If any point from this object, the perpendicular distance from this line will remain the same. Means the distance from C to this line and C dash is always equal. So this line is called mirror line. Mirror line. And the distance, the perpendicular distance from this line to the point and its image is always equal for any point B, B dash, C, C dash. And the position of the mirror line is essential when we are describing the image of any object. So the next one, that is rotation. So we have discussed reflection. Next one, that is the rotation. Rotation. Now, if we have one object and if we want to rotate, and point is given, that point is called center of rotation. Center of rotation. But here this point is center of rotation, and for this case, let's we rotate it in clockwise direction. In clockwise direction, 90 degree. So we have the shape in this form. Now here, like, this is the object here, this is the object and this is its image. Here this is the object here. When we are going for reflection, this is its image here. So this is the object here and this is the image. So in this case, when we are going for the rotation 90 degree clockwise, so this point is called here center of rotation. Center of rotation. So here the object change its position 90 degree towards in a clockwise direction. When an object undergoes a turning movement about a specific point is called the rotation. So turning movement, like here it's flip movement, here it is, in case of rotation it is turning movement. Turning movement. So here, in case of rotation, three components are essential. The first one is the center of rotation. First one is the center of rotation. Center of rotation. The second one is the angle of rotation. Angle of rotation. Angle of rotation here, that is 90 degree. And the third component is direction. Here we are going rotation in clockwise direction. So direction can be clockwise or anti-clockwise. So in reflection we have a flip movement whereas in rotation we have the turning moment. The next is translation. The straight sliding movement is called translation. Translation. In translation, it is necessary to give the vector, translation vector is important, and like rotation, in translation the point will not change, the sliding moment, the image and the object, the points, they will be like here. If we have one object here and if we are going for a sliding movement, and you can understand better if we are drawing these figures on the grid, on the graph, and if after translation with some like vector is your 6, means x is going from any point here, like this is a b c, so a point is going 6 in x direction and let 3 or y, so here 1 2, like here, let this is a dash, this is c dash, and this is b dash. So here every point is going translation, these are the translation vectors, and every point remains the same, the object and the image will remains the same. So the translation vector is the essential here. One more, if we have an object, if this is the object here, and let's we have a vector for this object, we have a vector like -4, x -4 or +4 and -3, 1 2 3 4 and 3 downwards. So these are the translation vectors, and this vector represent the translation of this is the object here in this case, and this is the image. So on the grid you have to draw, and you will understand that the translation vector is important to describe such a movement. So the fourth one is enlargement. When an object goes for either the positive enlargement or negative, scale factor can be positive or negative, but in enlargement the objects are always similar in shape. Enlargement. Enlargement, when an object undergoes enlargement, the shape, the image of the object the shape will remain same. The object and the image, they will be similar, but the object and the image may be smaller or may be larger. So two components are important for the enlargement. One is the center of enlargement and the second is the scale factor. First one, the center of enlargement. And the second one is the scale factor. when the scale factor is bigger, then we have the positive enlargement. So let's take one example. If we have a one object, and if this object is enlarged in such a way, this is the object here and this is the image. First, how to find, let this is A dash, this is B dash, this is C and C dash. For the enlargement, how to find the center of enlargement for the 2 points, point A and its image A dash, we will join these, and any other point B dash, we'll draw a line here, B dash, the 1 point on the object and one on its image. Where these 2 points meet, that this point is O, called the center of enlargement. And definitely the third point, that if we join C dash, then this will also meet at point O. So how to find the center of enlargement? We will join the points on the object and its image, and we will produce the line, any two line from these 2 points, the point line where they intersect, that point is called center of enlargement. Now second is the scale factor. What do you mean by scale factor? Means if this object is ABC, how much time, whether 1.5 times, 2 times, 3 times, 4 times bigger than the original this object. So how to find the scale factor here? Here we have OA and OA dash. We have OB and OB dash. We have OC and OC dash. Suppose here, for in this particular case, if OA and OA dash, if OA dash is twice of OA, if OA dash is twice of OA and OB dash is twice of OB, then we will say that here the enlargement is 2. Enlargement is 2. So here the enlargement is positive enlargement. We have a negative enlargement also. When we have one object here, that is A, B, and C here, and here this point is A is here, B and C, this is A dash, B dash, C dash. Then again we will join A with A dash, B with B dash, and we will join C with C dash. But in this case, this is the enlargement is, if suppose O, this point is the center of enlargement, but here the enlargement is negative enlargement. Enlargement is negative. So dear students, now this transformation is very simple. We have these 4 things. The one is your reflection, rotation, translation, and enlargement. And we have discussed in detail chapter number 31, that is vectors. So this PT1, we have the vectors in the syllabus. So let's discuss about the vectors also, a kind of revision. Always use the grid or the graph while solving the questions of vectors, and you should be very much clear about the addition, subtraction and the multiplication of the vectors. And these both topics comes under the transformation. So for translation, the translation vector is necessary. So you should go through these topics, and while solving your past paper, make it very clear that now for your session the chapter matrices is not in the syllabus, and this transformation is very now simple. So thank you very much.